Hi, in this tutorial we'll learn everything about MIDI programming and virtual instruments. That includes introduction to MIDI, setting up MIDI devices, creating MIDI tracks and virtual instruments, programming MIDI patterns and melodies, working with MIDI effects and arpeggiators, and mapping MIDI controllers for expressive performances. Let's get started. What is MIDI? What is the definition of MIDI? MIDI stands for Musical Instrument Digital Interface. It is the digital communication language that is a protocol developed to send and receive music performance data to and from electronic music instruments. With the recent development in computer technology and internet, MIDI became a simple and practical means to provide musical information because of the low data bandwidth it requires. It is important though to note that MIDI does not transmit audio and MIDI is not digital audio. Before MIDI, the old analog synthesizers used a system called control voltage, that is referred as CV, to exchange information between devices. MIDI was invented in 1982. A group formed by several electronic musical instrument manufacturers like Yamaha, Roland, Korg Sequential Circuits, and Kawai got together to develop a standardized protocol that can be used as communication interface and to be used by every electronic musical instrument manufacturers. The first synthesizer to be released with MIDI were with Yamaha and Sequential Circuits. Currently, there are two main associations that regulate the MIDI standards: MMA, that stands for MIDI Manufacturers Association from United States of America. The other one is JMSC, Japanese MIDI Standard Committee from Japan. Now let's see the type of MIDI connections. The MIDI standard uses a DIN, that's Deutsche Industry Norm connector, with 5 pins distributed over an angle of 180 degrees. From the 5 pins, only 2 are used so far to convey information. Every MIDI instrument will have at least two connectors: MIDI in, where MIDI information is received by the MIDI device, and MIDI out, where performance data generated in the device is sent out. In case MIDI information needs to be passed from first receiving module to the third, another type of connector is needed. This type of connector is called MIDI through. It retransmits the information received at the input, making it available to the next device in the chain. Although we don't have to worry about this kind of connections these days, but it is always better to know where all of these things came from. The new MIDI devices comes with a USB connection and works much more faster than the traditional ones. Now let's look at the performance parameters. A MIDI instrument converts performance actions into digital information and back. The most common information recognized and transmitted by MIDI are: note on indicates that a key was pressed. Note number indicates which key was pressed. Velocity indicates how hard or fast a key was pressed. Note off indicates that a key was released. Program number indicates which sound is to be used to play the note. Pitch bend slides the pitch of the note. MIDI channel: on which channel should the note be played. This information is converted into binary code and sent to the MIDI output. Globally, messages sent by MIDI devices can be divided into two types: channel messages and system messages. Channel messages are addressed to a specific MIDI channel, so only devices set to react to that channel will respond to it. The others will ignore it completely. Channel messages can be note on, note off, polyphonic pressure or aftertouch, control change, program change, and channel pressure. System messages are addressed to all channels and contain general commands such as reset, MIDI, tempo. All devices in the chain prepared to recognize them will respond. There are 16 MIDI channels with MIDI protocol. However, some hardware devices allow multiple streams of MIDI data, each using a separate output. This allows for tens and even hundreds of MIDI channels. If you have a very complex studio MIDI setting with multiple MIDI keyboards and MIDI instruments, each instrument will have its own channel, and each keyboard will control the instrument whose MIDI channel matches its setting. Now let's take a look at the MIDI modes. Mono or poly. Mono is an abbreviation for monophonic, and poly stands for polyphonic. This set the number of voices or notes an instrument will produce at once. Some synthesizer, usually old ones, are monophonic by its nature and can never be set to polyphonic. In mono mode, an instrument will end the previous note before producing the new one. This is useful when we want to imitate a monophonic real instrument like woodwinds, which will also sound more realistic and give better hand ear reaction for the musician. While poly mode is good for general polyphonic instruments like piano and polyphonic synths, for instance. Moreover, monophonic mode is the sense making situation to apply glide, which smooths the change of pitch between different notes. For example, glide imitates the sliding effect in violin. Now let's take a look at sequencer. Sequencer is a device able to record and play back a MIDI data stream. There are basically three types of sequencers. One is hardware based. It is usually a standalone box with dedicated CPU exclusive for recording, storing, and manipulating MIDI data. Next is built in. It is the combination of synthesizers, samplers with a hardware sequencer. The next one is software based. It will use our computer's CPU to run a specific software that performs sequencing. One of the great features of sequencers is the capacity to alter a MIDI performance in order to correct mistakes or create a new performance out of a radically different original. Examples of processing are cut, copy, paste, loop, transpose, change tempo or signature, change velocity, edit notes, and quantize. Quantization refers to the act of forcing events played to fall on the nearest beat specified. Over quantization will make a performance sound robotic. To reduce the mechanical feel of quantization, some devices provide a progressive quantization, just like this. You can simply right click here in the clip view and select quantize settings, and you can change the value of the quantization from here. Arpeggiators. Arpeggiator is a MIDI processor that takes in multiple MIDI notes at the same time and distributes them across time in a broken chord fashion. MIDI can be used for other applications as well, that is, show control, theater lighting, special effects, sound design, console automation, recording system synchronization, audio processor control, computer animation, and animatic figure control. That concludes everything. See you in the next tutorial.